Well, welcome to section one of the course here, talking about business information systems, and let's just dive right in. So, why do we want to learn about business information systems? Well, clearly, technology is something that affects every single part of our lives. I can't seem to, go 5 or 10 minutes without checking my phone or looking at email. So again, information systems and technology absolutely has infiltrated every single part of what we do, especially in business. And so we look at all types of organizations, whether it's a service industry or education. Clearly, you're watching this video on technology, and so it has really transformed everything that we're doing. So it's important to understand kind of the base foundation of how things interact, the different systems that are out there, and that's really what we're going to talk about today. So as we introduce these things, the information system is a set of interrelated components that collect, that manipulate, that disseminate data and information and provide feedback to meet the objectives of the organization. That's pretty generic and pretty broad, but really it's the catch-all. Information systems is the catch-all for everything else that goes on, all the technology that goes into support the functions of an organization. So it's meant to help them achieve their goals. Again, typically goals are stated differently, but from a broad perspective, they are to increase revenue and reduce cost, and that is really the whole reason for an information systems to exist. So when we talk about information systems, we want to understand the different nuances between data, information, knowledge, meaning, right? All of these are somewhat used synonymously, but they are definitely not the same. And so we definitely want to understand what these differences are. So data is again raw facts or material used to produce information. We want to think about data as a material coming in. It is simply a number. It is a figure. It is somewhat, well, it's meaningless by itself. It doesn't do anything for us. The fact that I go to a grocery store and I check out and the transaction cost was $24. Well, that's great. Is that about what I normally spend? Is it less than I normally spend? What did I buy? All of those things. So data in itself is not that helpful to us. It's only when we can organize that data into some sort of fashion that makes sense to us, where we can manipulate the data to help us really draw information from it. Okay, and so data doesn't provide meaning. We do. You and I do. As people, we are the ones that supply the meaning to the information. We supply the meaning to the data and why it's important. Obviously, a process is a set of logical tasks performed to achieve a defined outcome. Again, this is kind of the manipulation process. So we might find the average of something. We might find standard deviation later on in this course. We'll do some statistical analysis of data to help us understand or glean more information from the data itself. Okay, and again, knowledge is kind of the awareness and understanding of a set of information and the ways it can be used to support a task. Again, data, we go from data to information to knowledge or meaning when we're starting to look at these things. The basic building block, though, we have to start with data, and that is where everything else can be derived from. It visually looks like this. So we select which data is important to us, how we want to study that data. And then we organize it. We're typically trying to either rank it, put it in some sort of order. We're trying to find, what is it correlated to? How is it similar to other pieces of data? And so we want to put all of these things together. And then eventually we're going to manipulate the data and hopefully turn it into some sort of information. So for a business, this might be collecting all the hours worked from a record keeping system. And then we organize the hours worked maybe by operating unit to determine which unit has the highest direct labor cost. And then we can add more data to determine if those highest labor costs are also producing the most units. And even further, we can add measures of quality. So, are the unit that has the highest labor cost and producing the most units, are they producing the most quality units that we can? And so, again, all of these pieces of data kind of come together when we manipulate them to actually provide us information. That information should help us determine meaning and then make decisions from that information. Okay. Obviously, it's important that we get information in there correctly. There's a saying in technology that garbage in, garbage out. And so if what is being input into the system is not reliable data, is not something that we can count on, then it will produce will be absolutely trash. And so that's important for us to understand that the accuracy of how the data gets into the system is pretty important for us to make good informed decisions based upon what is coming out of our system. Okay. Again, organization information is not accurate or complete, well, then we're going to make poor decisions. We are going to, some of these decisions very costly. Okay. There's case studies upon case studies and research and literature. When we make poor decisions based upon bad data, it typically costs companies money. It absolutely costs people their jobs. And so we want to make sure that we are actually looking at the data and what it's telling us and how important is it. Okay. Characteristics of quality information. So all of these pieces and parts are going to be some sort of facet of quality information. One, we have to be able to get to it. We need to be accurate. Okay, it's error-free. Again, garbage in, garbage out kind of concept. It needs to be complete. We need to have all of the different pieces and parts that go into it. We need to understand that if it's not complete, our decision will not be as accurate as it could be. Economical, right? We shouldn't spend $20,000 to gather information to solve a $5 problem. That doesn't make any sense. Flexible. It needs to have multiple purposes. It needs to be used not only by myself, but other departments and other people to also help them make decisions. And then obviously relevant is talking to the timeliness of the information, right? How does that actually come together for us? It needs to be reliable. Again, it can be trusted and used by other folks. Secure, meaning that it is not accessible by unauthorized users. This is one of the biggest pieces and parts in today's cybersecurity and just the security of data. We'll talk a little bit more about it, but such a key component to information technology. It needs to be simple. Although the process and the manipulation of the data may be complex, the uses of it and accessibility to it must be simple or it simply won't be used. So if you've got a bunch of awesome information that no one understands or knows how to use, it's not really that awesome, is it, right? Timely and verifiable, again, just more pieces and parts to quality information. Okay. And so the process for us is going to typically look like this, where we collect the data, we input the data some way, shape, or form. We'll talk about the different ways to do that here in a little bit. We manipulate the data through some sort of process. This could be a mathematical process, as we'll learn later on in the semester, but it could also be a simple gathering and kind of aggregating, adding up all of the data. Okay, there's some sort of typically a storage process in here as well, and then there's some sort of output, some sort of dissemination of the data. So whether that's you know, printing it, whether that is a visual display, which is like 99% of all information is simply displayed visually on a computer someplace and stored, and that's about it. And then there's always a feedback process. Are we getting the right output? Did we test and get what we thought we were going to get? And so that's an important part of the process as well. So systems are typically described as either closed or opened. A closed system is the guy on the left here. He is on an island by himself, typing into the sand. The only way to get information in is to manually input it. The only way to get information out is to visually look at his little sand computer here. Okay. The opposite of that is an open system, where systems interact and interface with other systems. And open systems typically referred to as like a subsystem. And again, by definition, a subsystem are always open because they are a component of a larger system and therefore must receive and send information to and from other systems. Okay, most larger organizations use an ERP, which is an enterprise resource planning system, to help, kind of combine and gather up all of the subsystems to help push towards the goal of the organization or the company. All right. So again, two different types, open and closed. One is there is no interaction with outside systems, and the open system, constant interaction. It is just a single part of a larger overall system for the organization. Okay. We have computer-based information systems. Again, this is going to be, by definition, the set of hardware, software, databases, telecommunications, people, and procedures. All of these kind of go into making up a computer-based information system. Again, companies are integrating their computer-based systems with other ones. So I do some active trading, and the system that I use, they integrate with 4 or 5 other investment tools or trading companies, as well as data feeds from different sources, different networks throughout the country. And so, but all of these pieces and parts, they ultimately make up the technology infrastructure. Okay, so all of the various components of a computer-based information system comprise the technology infrastructure. And these are the shared resources, again, that make up that foundational piece of our computer-based information system. Okay. If we look at the components, right, they are going to be vast. Hardware, we're looking at computer equipment used to perform the input and process, storage, and output activities. We'll have software that's going to run the computers and govern the operating systems. We'll talk more about that. We'll have databases that help to store the information and collect it. The telecommunications, which are going to be the electronic transmission of signals for communications to other networks. When we talk about the people, right, we want to make sure that this whole thing, all of our business systems, all of the processes that we have are built for people and the business processes they normally go through. So, and again, most of these things are now stored in a cloud type environment, which again we'll talk about here shortly. So, but in essence, the internet, right, the world's largest network of computers, is just thousands and thousands of connected computers to one network, and providing that information. Okay, so again, all of these are going to be components for us in our computer-based information system. Again, the cloud piece here provides the software and storage just via the internet, and so I no longer need to have um, all of that capacity on my local computer. The idea of like a netbook or a Google Chromebook, is that they don't have the operating system on those laptops anymore. They are all now all stored in the cloud. You access everything from the internet. So as long as you can get to the internet, you can get to everything you need. The internet goes down, that's a problem. That's not good at all. But again, the web allows for this growth in cloud computing, where that Amazon's a big one. They have Amazon Web Services, where they can host a whole bunch of technology for you, and they're responsible for the upgrades. They're responsible for all those things. So it's a nice service that they provide for businesses, and it makes sense to have that hosted someplace else. But again, they're using the exact same hardware. They're using the computers. They're using servers and all of those things. But it's just they're responsible for keeping track of it all. So. All right, intranets versus extranets. So an intranet is just as it sounds. It's the internal network typically found in an organization. A lot of times, if you have some sort of shared drive, hey, that's saved out on the P drive or the S drive. That is your intranet. Some organizations have spent vast sums of money building up their intranet to be a knowledge base for all their employees. And again, it's only accessed for those individuals inside the organization. An extranet is exactly as it sounds. Again, we can bring in business partners, we can bring in customers to access our resources and access our information to kind of open it up, right? So one's a closed system, one is an open system, if you think about it that way. Okay. Um, when we talk about people, most important element of any computer-based system are the people. Again, these systems are built around people. They're built around the business processes that people have created. So again, almost all systems are built around the way people work and the way people operate their lives. And it's rare that you'll get a system that's really successful that completely changes the way we used to do things. You can think about like a Facebook or a Snapchat that is changing the way we communicate with people. But for the most part, if it's not built the way I'm already doing things, I'm probably not going to use it and it probably won't be successful. So, again, people by far are the most important part of a computer-based system. There are various systems here. We'll go through these here, but they these acronyms. I feel like I'm talking in the military with all these different acronyms, but business information systems, there's so many of these. The first one here we can look at is the MIS, or Management Information Systems. Again, it's going to be used for to support the decision for our management team. It will do some high roll-up levels. It'll have controls that they can use information for. The TPS, or Transaction Processing System, you were thinking about like a point of sale. So anytime you go to the grocery store, and that's a POS system, a point of sale device. It's any system that records transactions. Okay, they are used to gather data at the point where the organization transacts business with other parties. So we're thinking about like the edges of the corporation. Did we buy or sell something to somebody external? That's going to be a transaction processing system. Our supply chain management system is going to fill the role and help support manufacturing and ordering and shipping and billing and raw materials and inventory, right? Everything to do with that supply chain management process. An ERP is an enterprise resource planning system. This really helps to get all of the entire organization kind of pushing in the same direction and all working together. So if it's accounting or billing or production or quality control, that ERP system, it's a bunch of subsystems that work together to help the organization achieve the goals that it has. Um, the business customer resource management. So the CRM is just as it sounds. It is the outward focused. It helps to track the customer relationships. Who did I talk to? When did I talk to them? What was their last sales process? What was the contract language associated with the last agreement that they signed? What's the pricing level that they're buying at? What's their billing rate? All of those things. So CRM is going to help track all of that. A business BI, or business intelligence system. This is where we're looking for trends, and these folks are going to look at the all of the data of the organization and really bring that together and try to find unique trends or new ways to look at the information to find maybe some correlations about, hey, when customers buy this, they also tend to buy this. We should make a new package and price it this way, and figure out ways to service our customers better. So the BIs are actually combing through like all of the data within the system in order to come up with something that's kind of new and different, or new perspective, a new solution that customers ultimately would probably want, but no one's been able to identify it because all the subsystems kind of operate independently. The DSS, which is Decision Support System, is exactly as it sounds. It helps. Typically, it's found in upper management, where they're looking to distill all of the information from the organization into like a dashboard type system, where they can get one graph, one table, one number, and really help to get to kind of a control point or make some decisions around those things. So the expert system is the idea that there's some expertise that we have, some knowledge that we have, and so there may be a certain individual or person within a company that has a specific knowledge set that we can put into a system and help the rest of the organization benefit from that knowledge. So, literally, an expert system is built around an expert, and then we disseminate that system to the organization. It could be a program or an app, and then we help the rest of the organization make better decisions based upon that app or that knowledge of that expert. The last one is a graphical information system, a GIS. GISs help support GPS. So whenever you pull up Google Maps or whatever you look at properties online at Zillow, right? These are all graphical information systems that supply you information about how far things are, what the distance is from point A to point B, or how much that house sold for. And so there's a whole bunch of systems that are built around these things. Okay. Again, we look at the base level here. The business information systems are often integrated into one product, but are delivered by the same software package. So the first basic kind of core is this commerce type thing. We'll talk about e-commerce and m-commerce, but e-commerce, mobile commerce, enterprises, and then we kind of build on top of that some sort of management information, some decision support systems, and then finally that knowledge management, that special purpose kind of entity. So the first one is, as most businesses, we need to sell something. We need to create revenue some way, some shape or form, and that's where the commerce is built upon there. Okay. So we look at e-commerce. Business transactions are executed in all types of ways: business to business, business to consumer, consumer to consumer, between public sector, private sector. There are so many different types of transactions, and again, different systems are built to help support those things. So a very common one in a business to business would be a Salesforce, which is a CRM that helps to keep track of all of the customers' interactions and what their sales have been and things like that. Oracle also supplies the same thing. When we talk about business to consumer, we're looking at Amazon. We're looking at Walmart. We're trying to understand how they're going to conduct and interact business. I go to Amazon, all of a sudden I can see the deals of the day, but I can also see what I purchased, and other people that were looking at what I am looking at now also purchased this. That's all done through a business to consumer type system. Okay, so e-commerce offers tons of advantages. Just streaming the workflows, it allows people to come in and be open 24 hours a day, 7 days a week. People can get on and shop when they want to. We don't have to have the cost of a storefront, a brick and mortar, right? And so that's some of the advantages there of an e-commerce system. And in-commerce really is talking about the mobile piece. And so this is where we can use mobile devices and our phones to actually help create purchases. This is huge in the gaming world and apps online. And so that's kind of important. Um, the m-commerce is by far one of these areas where it's growing. And I was on Twitter the other day. I clicked on an ad for some Adidas shoes, and as I was looking, I saw the link change like 3 or 4 times, and they were tracking, in essence, the analytics of trying to determine, okay, who is Brock? Why did he click on this ad? How many times does he get on Twitter? They're pulling all of that data before they serve me up this ad for shoes, if that makes sense. So it's kind of interesting how the whole mobile commerce works, and again, we'll continue to see that grow and grow as we continue to progress into that mobile technology, and it becomes more the norm for us. So let's talk about some of the roles in information systems. These are some of the more common roles that we'll find. A system admin is going to manage and maintain the operating system. The webmaster is going to be responsible for the intranet, the extranet, the website. The DBA, which is the database administrator, is going to focus on the storage and warehousing of the organization's data, making sure it's secure, making sure that there's backups, making sure there's proper redundancy. The CTO is the Chief Technology Officer. Typically, they're focused on all kinds of areas of just the technology itself, the software, the hardware piece of it. The CIO is a Chief Information Officer. He's kind of like typically he sits on the executive team. He'll have some sort of high VP role and will oversee all of the technology of the organization. And the last one here is the Chief Security Officer. Again, they're going to be focused primarily on security and making sure the data is secured, making sure they're meeting their legal requirements. And again, they'll work with all the system administrators, the DBA, the webmasters to ensure that technology is secure. Visually, here's what it kind of looks as the overview. Again, chief information officer at the top, typically a chief technology officer. Sometimes those roles are interchanged. Sometimes the actual titles will vary, but for the most part, this is kind of standard within the industry. And so we'll have operations that will help support the operating team. We'll have development that's actually looking at developing technology, and then support. This is the IT, the help desk folks that are kind of helping you out on your day to day. Hey, my printer's not working. This isn't working properly. Those kinds of things. So that concludes section one. Please feel free to watch this video as much as you can, as many times as you need to, and then take notes. And then also, I'd love for you to complete the interactive Q&A at the end of the Peregrine section one.